Alright, see what we have here. 2161 partition array by given period pivot. You're given a zero index array nums, and you want to rearrange the nums such that the following conditions are satisfied. Every element less than the pivot appears before every element greater than the pivot, okay? And every element equal to the pivot appears in between the elements, okay? The relative order of the elements given, the relative order of the elements less than the pivot and the greater than pivot is maintained, okay? More formally, consider every okay, return nums after the rearrangement. So the pivot is 10. So 10 would go here. And so the stuff that is smaller than 10 would be like 9, 5, 3. I don't understand why is this. How is this a medium problem? This looks like, do they want me to do this in one pass rather than like 3 passes? I could still do in one pass. Let's rearrange nums. Rearrange nums. Return nums after rearrangement. Oh, is it? So they want to, since it's a list rather than an array, you can't create another array for it. So you have to do some rearrangement. So these have to be swaps. And it's not a very large amount of numbers. You have to do swaps. Okay, I'm gonna say this should take me 10 minutes. All right, let's do a straightforward solution. So let's say pre-spots. I'll keep track of all the spots of the values before. I don't know. Count equal, and then post spots. Why wouldn't I just keep track of the actual values? Yeah, it's 10, 12, 14. I don't know. Smaller is an array of values and larger is an array of values. And count equals for every value in my nums if value is less than the pivot, smaller dot append this value, else if the value is greater than pivot, then larger dot append this value, else increment the number that is equal for every index in the range of my list nums I nums I is let's say actually I is just an index I track for every value in my smaller nums at I is equal to this value, increment I, for k in range of count equal nums I is equal to the pivot I plus equals 1, and for every value in my larger nums of I is equal to this value, increment, and then return nums. Going too slow with this. So this is slower. Let's see if I can think of. So if I kept track of just the indices where they would swap to, if I look at a number, it's either going to go to the front or it can go to the front directly, or it can go to the back directly. So like 9 goes to the front, and then 12 goes to the back. I don't. Okay, I guess you could possibly get away with not having the smaller index or smaller array here. Don't know how you can get rid of having the larger one. So let's say if the value, let's say I have an index here. If the value is smaller than the pivot, then just move that to the front. And then at that point, you can store the equal and store the larger ones. Shoot, this should not be I equals 0. This should just keep on using I. Okay, I mean, I got rid of the smaller array. Is that? No. So is there a one pass way of doing this rather than multiple passes? So the pivot is an element in nums. So if I see something bigger than the pivot, like the 12, I can move it to the back. And then if I move it to the back, then I need to know what to do with that back spot. I mean, this one is whatever, it's just a count. It's just equal to the pivot, so that doesn't need to get moved. And then I see a next small one. But if I see something big, in the back, then what do I do? So like if 12 is here, which is bigger than pivot, but 14 is the last number in the array, then I want to so the 14 should end up being before what do I want to append onto the numbers? 14 should end up being before it. How do I get away with not having a larger array? That is the solution. So I move stuff to the front. I mean, so 12, maintain order. So anything that's larger in the back would stay in the back. So if this is a 14, then the 14 should remain. And then the 12 would go to the first, the 12 would go to, would backward traverse until it sees the first inappropriate one, or let's say the first inappropriate one is a small one. So it would well, it wouldn't be the one that swaps to it. It would be the one, it would swap to the next largest one and swap there. All right, let's go for another 10 minutes here. So the 12, so let's say this is 14 here. So 12 would need to be not swapping there. I guess I could do more swaps. Like I did 12 and 5 swaps. And 12. 12 and the 5 would swap. And then the 12 and the 10 would swap. No, the 12 and the 10. The 10 just doesn't matter. No, the 12, let's say it's 12, 10, and like 3. The 12 would swap with the 3. Nine. So 9. 5 would swap with 12. And then the next one is this 3. But the 12 wouldn't swap with the 3. The 3 would want to go in the 12 spot, but the 12 would want to go into like this spot. Swap to the front. Keep track of the ones that you want. swap to the front. Everything that is between that and the swap needs to be moved. Yeah. It just has to be a fast way of doing this. So you look at the values. 12 would be before the 14. So if you swap the 5 to here and 3 to here, 12 would be here. We can store it. Storing in a larger set seems to be very reasonable. Swap. You have to read all the way to the end to know that you have swapped enough. I believe. So let's say 5 swaps with 12. So 12 is here. And then 12 swaps with 3. And 12 is here. I kind of wish they would just give, like, you cannot create new lists or create new sets as a constraint on this to be sure that you're doing it as intended. Because obviously this is just a very basic solution. Is there a hint here? Could you put the elements smaller than pivot and greater than pivot in a separate list as the sequences? The separated generators, could you... what the heck, it's too easy. Alright, let's see what the actual faster ways of doing this is. Are you fucking kidding me? How is this? How is this running fast? Oh, I see. They did operations on the array, so they created a new array. Whatever.